Despite the fact that genetics is the study of amazingly complex information systems and advanced tiny machines all working together, some people have still tried to make genetics support evolutionary theory. One of the ideas they've created is molecular clocks. The molecular clock is a technique that uses the mutation rates of biomolecules to deduce the time in prehistory when two or more life forms diverged. The biomolecular data used for such calculations are usually nucleotide sequences for DNA or amino acid sequences for proteins. We're going to use the rate we can't measure of a process we've never observed to determine how long ago something we haven't observed that can't happen, happened. You know, sometimes when you accurately describe something, it sounds like you're being sarcastic when you're not. This is one of those times. Consider the following. Over the course of millions of years, mutations may build up in any given stretch of DNA at a reliable rate. For example, the gene that codes for the protein alpha-globin, a component of hemoglobin, experiences a base change at a rate of 0.56 changes per base pair per billion years. So who's been tracking the mutations in that gene for billions of years? Well, clearly nobody. But maybe they just found some really old DNA and compared it to more modern DNA. Well, consider the following. The half-life of DNA is just over 520 years. That means in 7 million years, every single bond is broken and the DNA is no more. How old are those dinosaurs again? But this gets worse for evolution, because this study has led to an understanding of genetic entropy. Genetic entropy is what we call it when neutral mutations build up until they become lethal mutations. Neutral mutations are kind of like the tar from cigarettes. The amount of tar from your first cigarette probably won't kill you, but gradually over time, your lungs start to look like a freshly sealed driveway. Let's think about the facts of the case just for a moment without any presumptions. Genetic studies tell us two things. First, that every generation gets more than 100 changes made to their DNA. Second, that as little as one letter being changed can kill you. Now, which conclusion do these facts lead to? The idea that there's been millions of generations of blind, accidental, random mutations? Or the idea that our species was made 6,000 years ago with a perfect genome, which has been slowly breaking down over time? So when you study this molecular clock business and you see how fast mutations are accumulating, you find out that those mutations are harmful. Those mutations turn into things like cancer and birth defects. And what this tells us is that we cannot have been on Earth for 100,000 years, or we would have gone extinct already. But there's an even bigger objection to this molecular clock business. Stasis. Stasis is what we call it when things don't change for long periods of time. Now, you know I don't buy the deep time evolutionary dates, but let's assume them to be true for a minute. You know what a horseshoe crab is? Well, according to the deep time dates, horseshoe crabs have been on Earth unchanged for 500 million years. How can you possibly say that DNA is evolving at a predictable rate when the horseshoe crab has gone unchanged for 500 million years? If you can assume this molecular clock business to be legitimate, meaning that DNA is changing every generation at a regular and predictable rate, how can you possibly say a species has remained unchanged for 500 million years? But if you can claim a species has been the same for 500 million years, how can you possibly say that DNA changes at a constant and predictable rate? Once again, the clock has run down on Darwinian evolution, and biblical creation is the faith that fits the facts. Thanks for watching. The next chapter, and now all the chapters in our Defining Evolution series, are up on our new website, abitoforange.com. Thanks for liking, subscribing, and sharing this with friends, and happy nachos!